have
This
structured
conference
it.
will now be recorded.
Okay, let me connect this stuff. kubectl get pods. Another running kubectl get all. So I'm going to delete all the stuff. We'll do the exercise from the point one. Okay. Delete, deploy SVC. Right. So if I delete the deploy, automatically it's going to delete the replica set, it will delete the pods, delete the deployment. So we don't need to give these details. Deploy and SVC will be the extra one. So I'm going to pass the deploy and SVC. Then my deployment name is Nginx, and my service name is also Nginx. Now notice are found. Let's open the slide. So now I'm trying to deploy the Nginx freshly. kubectl get all. Now you can see a pod is created for the Nginx, and the deployment is created for the Nginx, and the replica set is created for the Nginx. This is fine, we know very well. And the next one is service object. Right? So I'm trying to create the service object for the Nginx so that you can access into the outer world. Service is created. So now if I say get all, we'll see 4. Right. So here, okay, we'll discuss that thing later. Okay, now our setup. Right, so here kubectl autoscale something we have given, but prior to that, we need to set up the metrics. Correct. So this metric has to set up this way. Here we have faced the issues. Right. So here the problem what we have done yesterday is I'm trying to give millicore mi. Actually, it should be m only. There I'm trying to give mi. That is the reason it is not allowed us actually. Right. So now here kubectl get svc. This is our Nginx and this is the port number allocated to our Nginx service. kubectl get deploy. This is our Nginx deployment and this is the state. Right. If you want to see the details, what we can do, kubectl describe. Describe is the command which is going to give us more details. Describe deploy. Which one? Nginx. Complete details. Deployment details. So here you can see deployment Kubernets is the extension pointed to WNV. Labels are Nginx. Right. So now here there were no metrics allocation here. So that is the reason this that HPA is not going to work, right? So let me see. Let me show you again that one also cube CTL get HPA. No HPA is found. Let's set up the HPA. So set up the HPA is nothing but configuring the auto scale. So now I'm trying to configure the auto scale for the deployment Nginx. Right now minimum is 1, max I want to 5. That is the threshold value, CPU utilization of the pod. Now QCTL get HPA. Now you can see the HPA details, horizontal pod auto scale details. So this is the way which target is not showing properly because the resource limits are not configured. Right. So now here we need to set up, we need to get this content means we need to set up the resource limits. So right, so let me delete the HPA and configure the resource limits, then we'll try it again. Because some hidden character or something is not allowed here. Okay, fine. So deleted HPA got deleted. Now I'm trying to set up adding the resource limits into our pod. Right. So if you want to add the resource limits into the pod means when the pod is going to create at the time of deployment object creation, right? The deployment object will be taken care of replicas, pod creations, and the deployment creation, right? So there we need to configure. So means you need to modify the deployment configuration file, nothing but the deployment manifest file to add the resource limits, right? So for that, right, multiple ways to do this exercise, multiple ways. Suppose if you have the files handy like this, right? So you can go to the file and you can modify the file. Yeah, see here we are trying to give MI. That is the reason yesterday it is throwing an error actually. You should give only M. So right, so add the resource limits, then apply it, reapply it, so that it is going to override with the existing. This is one way. The second way is straight away go to the file and modify it. Straight away go to the existing file and modify it. Right. So the second way, straight away go to the file and modify it means use the edit command so that it will open the existing file, modify the file, and save it. Automatically, it will take the new changes. You don't need to do the reapply like that. So multiple ways you can do. If you have the files handy, go to the files, change it, apply it. If you don't have the files handy, then you can go with the edit command. Right now, we don't have the Nginx service files or deployment files. We are taken from the community. Now I'm going to use the edit command. Right. So now here kubectl edit deploy Nginx. So now this is the deployment of Nginx details. And here in the container section only, we need to add this one actually. And wherever the containers are going to create, that section only, this resource limit block has to be added. So now this is the containers creation section. So here we need to add. So I will go to the file section, files property. Here, let me add this one. Right. So here, resources, limits, resources, and limits. CPU, $100M, requests CPU, 100M. That's it. So limits CPU, request CPU. So I'm giving them both same, but usually should not be both the same, right? So minimum and max limits. Right. So to see the exercise, I'm giving the both the same values, then save it. Resources, limits, requests, CPU. Spelling set resources, limits, CPU, requests, correct on it. Edit, cancel, no value changes or saved. What happened? Yes, now you can see it is deleted. It is modified. Now apply the autoscaler. The autoscaler is applied. Now kubectl get HPA. It's still it is not getting. We'll wait for 1 or 2 minutes so that it will be updated. Kubectl describe HPA and Nginx. CPU request pod unknown. Fail to compute output 47 output critical the CPU and execute the metric on the metric section from the resource metric API. Right. So now see here, we can see we are getting the percentage CPU utilization. Right. So when I set up that metrics, now the CPU, the HPA will try to get the metrics information from the parts. So right now there was no load on the part. That is the reason we are seeing 0%. Right. The engines are running Ideally, that's it. We are not hitting the event. We are not passing any request to the Nginx servers. Here, servers means our containers. Zero, we are going to see now. kubectl get HPA. Right? You can see here 20% is nothing but our target's threshold value, the CPU threshold value. So when the target reaches 20% of the CPU utilization on the pod, then your pods are going to go for increasing up to maximum of 5. Like that is the process. So when the load decreases, automatically again it will come back to the normal state, minimum 1 pod. Right? So that's what here you can see. 1 to 5, min 1, max 5, and deployments of pod right now. One is current and one is the desired. Right? So, fine. So now here I want to check that one whether my auto scaling is working properly or not. Means you have to hit the server. You have to hit the server continuously. Port number kubectl get SVC 30106 30106. Right, so likewise I need to hit the URL continuously. Then some load will go to the my server. Still like in the next like every 5 seconds or like that is going to capture the load. So in the next load it will take maybe 0.1 or something because here I have hit more than twice or thrice. Right. So now this is not the correct way to check the load. You cannot hit something like that. So for that we are using the tools. We are going to use the tools to check the this performance stuff actually. Performance verification and applications. We are going to use some tools. Right. So let's see. Here which tool is available for us to test it. So Seize. Seize is a tool from our Linux side uh, to perform the testing on our application. Not only on our application, any application. Right. So means what it will do, it will try to hit the URL. It will try to hit the URL and will try to put some load on the application. Right. So let's try to set up the Siege and see. So here let me web server load testing to see the web server load to check the web server load. Right, the Siege can be utilized. There are multiple tools are available in the market. One of the tool is Siege. Right, so from the Linux side. So now I'm going to install the Siege. So in the meantime, kubectl top parts that 1 millicore, 2 millicore memory. Right, this is what the utilization. So remember, by default, you cannot get the utilization of the resources. Once you install the metric server only, we are going to see this information. Remember this point. So now here, I am trying to install the tool Siege. Go to the server and apt install Siege. From the Ubuntu side, first we need to update, then install the Siege. It is saying it is already installed. It is having 4.0.4 version. Siege is already there. Right, we are good. Then testing. Right. So web browser testing. Right. So web browser testing is nothing but hitting the URL. That's it. Right. So now here with the Siege, by using these options, you can hit the URL. So this is the URL, right? So now our URL will be this one. This is how we are right now. Now the command is -q quiet mode. -c concurrent requests. Right? The request has to pass concurrently, continuously. Then how long you want to send? -t m for minutes. Sending the request continuously for 2 minutes on this URL. That's it. So now here, let me take this command, copy, and paste it here. Then what I will do, I will open a new window, and there also will open the same server. I have opened the same server twice. Now on this server, kubectl stats. Stats will be the Docker command. I'm trying to see whether I'm going to get the information. No, it is not working. Fine. Fine. kubectl top parts watch -w. Okay, -w is not working here. Is address is a stop. Okay, so now this is the CPU utilization. You can observe here. So now here, let me try to run the command. So 2 minutes, I am going to send the request. Now here it is sending the request in the background. So let me see the top parts. Now we can observe here CPU utilization become 100 milliwatt. That means it reaches the max. So we are so in the resource limits I have configured, if reaches the max, don't go for the beyond. My limit is 100 M. So that is the result. You will see only 100 M. But in the background, what will happen? It will try to create the pods. See, 5 pods are created like that. So like that. So now here our auto scaling is working fine. When my CPU utilization reaches 100%, is nothing but here 20%. For the 20%, 100 M is the highest limit, 100 millicore of the CPU. So when the 100 millicore CPU reaches, so in the background, your HPA started creating the parts. So now here my max limit I have given as a 5. That is the reason only 5 parts are created. Even though it reaches beyond the 100 M for the rest of the 5 also, it cannot because the threshold value for the parts are 5 only. So there you can give 10, 20 like that based on the system configuration. Right. So now here my seize command is completed. It came back normal. Means now the load will be reduced slowly. Now the 100% will become 80, 70, 60, something like that. So now when it's going to release the load, then automatically these parts will be deleted. See, now 0, 0, 0. So nothing, no load on the containers. Means the load is gradually decreasing. So likewise, parts correct. Right. So the next time occurrence, it will be like a kind of monitoring theory here, like it is going to check every 5 seconds or something like that. So now in the next occurrence, it will start deleting the containers. So now here because I don't see any load on this containers, right? So in the right. So this is how the HPA horizontal for autoscaler on the Kubernetes side. So let me go through once again. So first thing will be you have to set up the metric server. So metric server is nothing but like an agent. It will be work on your parts, means it will monitor on your parts, and it will capture the resource utilization, nothing but the CPU and memory utilization. Then based on the auto scale how you define, based on the threshold values, it will going to work on the parts, means work on the parts means creation or deletions, whatever it may be. Right? So metric server has to be set up. Then once the metric service is configured, then whatever the services, I mean to say our application, the deployments, what are the deployments we are doing, on the deployment we need to add the resource limit block. So these two are mandatory: install the metric server and add the resource limits on your containers. Containers the pods. So once you added both, then it will start our horizontal pod will start working on that one. So then this is the testing practice, but in the real time you can leave it, so that when the load comes into the browser, means the application, automatically parts are going to scale up. When the load will be decreased, automatically the parts will be deleted. In the background, we don't need to bother about it. Automatically your cluster will be taken care. Right? We'll wait for a few minutes. It will be terminated for sure. Right. So now here, yesterday I forgot to tell you like a kind of understanding concept. So now here, Kubernetes is like an ocean, frankly speaking. There are many components other than the Kubernetes. Many components. Like we need to understand the links, right? So my suggestion is whatever the class, like whatever the components we are seeing here, try to understand the components first. Once you understand the components, the other components which are linked or which are needed for the cluster, then you will easily catch those components. Means okay, this is the setup I have, and these are the components right now I'm using it. Now the next component I want to use. So where I need to fit. Once you know the architecture and the understanding of the component, then you easily can understand the new components, where to fit and how to use it. Right. So now here, The Kubernetes kubectl get SVC. Right, we know SVC is an object which we are going to use for to, which it is going to use as a load balance in the cluster, and the service object will allow us to access the application with the service type like node port, load balance, or something like that. Correct. So now, how this service object will be works? This part I forget to explain it. Guys. So let me take. So suppose this is my cluster. One second. Guys. This is my cluster, and in my cluster, suppose there are two nodes are there, right? Forget about the master because master is not going to take any load. So now there are two nodes are running, and here I have a front end container and a back end container. Container means here the technical term is pod. Pod will be behind the container. Here I have a front end pod and a back end pod. This is front end. This is front end. This is back end. This is back end. Right, which are right now there are four pods are running on the two nodes. Right. So now when the requests are sending to the front end, right now the front ends are nothing but these guys. When the requests are sending to the front end, now the front end has to be communicated with the back end. Then what is the guarantee that the back end is also available on the same node? Because we are not telling that cluster that go and deploy on the same node where the front end is running. We are not going to deploy. That is also possible, but in the reality, we are not going to use. I will tell you, I will show you the option also. So now here, I am not anywhere mentioned in my deployment files or my manifest files that deploy my backend also in the same node where the front end is running. No. So then maybe your backend will be this one. Then yes, because your cluster will be deploy the components, but nothing but your resources and the nodes. So the node can be any node. Right. So now your front end will be running on one node and your back end will be running on some other node. Yes, that is possible. Yeah, that will be happen actually in the cluster. Now, how we are going to tell, hey, you go and connect to the back end. You go and connect to this back end. Like how we are going to mention, how we are going to tell. Who will take care actually? And who will take care this process? That guy will be the service object. Service object. Now this guy will take care of the request routings. That's why we are going to call this guy the load balancer. Right. So now here we are not going to hit the application directly to the container. We are going to hit the service. Right now, when the requests are coming to the service, then this guy will take care. Okay, you go to there or you go to here like that. The load balancer is the load balancer. Now that is fine. Okay, now we understand. Okay, the service is the object which will be route the traffic to the pods. But how this service will understand these are belongs to this pod and this pod are belongs to one service, one application, one module, and this pod and this pod is belongs to one application, one module. How this service object will understand? How this service object will know? That's where labels, right? Labels are coming into picture. So we are going to map the labels of which labels of the pod, right? This is the pod. Now we are going to call it the pod, right? Map the pod labels or match the pod labels to the service label. So whatever the service we are going to create, now the service for the service, we are going to mention a label. Now that label we are going to match with the pod label. Then once the matching is happened, then your service object will understand, okay, these guys are belongs to one group, so that I need to send the request to only these two. So that's what the role our service object is going to play. Then how can I check that one? Okay, fine. Who will do this job? The mapping. The mapping, right? So now here, once the labels are matched, my pod label and service object labels are matched, and then these parts are joining to the service object. So who will join this part to the service object? Who will take care? Those guys are nothing but core DNS. Core DNS is a pod which is going to run inside our cluster. This guy's job is to when there is a match happen between the pod and service object, automatically the service object will be updated with the pod details when the labels are matched. This guy duty. Right? You can check that work guy also. kubectl kubectl get pods. Right? The core DNS, kube proxy, wavenet, all are belongs to the system namespace. Get pods -n kube system. These guys. Right? These guys' job is to this is the one, right? When there is a matching is happen between the pod labels and service labels. This core DNS will update the service object by adding those pods into the service object as a group. This guy to the proxy is nothing but our communication, right? The pods, whatever the pods are running, those guys are going to use pod network. Those guys will be in the pod network. So now the pod network, suppose if I take it something like this is the pod network. No, not this is the pod network. Right. Now this is under the pod network. These pods will be deployed. So now the communication between the pods, right? It will be taken care by the few proxy. This guy. Right. So this is the networking. Finally, the main communication. Right. Those are the master communication. Okay, fine. We have discussed about these things. So now this is the guy will take care of the mapping. Mapping means the update of the service object with the parts, with the part. Right. So how can I see those information? kubectl get svc. So now this is my service name kubectl describe svc nginx. You can see there is a property called endpoints. Right. So now these endpoints will be updated, nothing but are added into the service object. So now who is this guy? 10.36.01, nothing but your pod. So kubectl get pods -o wide. You can see my pod IP is 10.36.01 and pod with the port number. What is the port will be running for the Nginx? Default will be 84. Right. So now who will take care of these updations to the service object? Our core DNS. Right. So again, when I'm going to launch one more replica, right? So now the replica is launched in other node. Now your core DNS will fetch the information. Okay, when the new pod is created, what happened? Your core DNS job is the same. When the new pod is created, then it will go and search the label. Now it will search the label. Okay, it will take the label, then it will go to the service objects. Right. Now it will try to see which service object is matching with the label name. So immediately this pod will be mapped with the service object. So now the service object will be taken care of. Whatever the requests are sending to this particular services, it will be routed like that. In the background, these guys will be work like that, right? So now here kubectl get pods. Now see our pod count becomes one. Your metric server, right? Our metric server, what the metric server is done, right? It check the load. Now the load becomes 0. So now automatically in the background the containers are gone. The pods are gone. It came back to normal state. One is my desired. Yes, one is running like that. Right. So let me try to add the replicas kubectl scale hyphen help. We'll take this one. This is Nginx. And here I'm going to tell launch 10 containers. Right. Containers are nothing but here the parts. 10 parts. Current replicas are 1. Enter. Kubectl get parts watch. If I give watch, it will show you what's happening in the background, right? And the interactive mode. Terminated. Okay, the HP in the background, the HP is working. That is the reason even though I have given the 10, it is given only 5. Right? The limit I have mentioned is 1 to 5, right? The horizontal per order scale. That is the reason it's not allowing me more than 5. Okay, fine. What is it do? I need a couple of parts. So now kubectl describe svc nginx. Now we can observe endpoints become 5. 5 endpoints. 1, 2, 3 plus 2 more means 3 plus 2 5 because there are 5 pods are running, right? So who is taking care here? The core DNS. The core DNS will be taken care how? With the label names. So whatever the label name we have mentioned, nginx, this is the label name, right? The selector will take the nginx and will go to the deployment object and search for the label name nginx. Then if the matches, then automatically the pods or will be added to the service object. Core DNS job is the same. Then all the requests, whatever the requests are passing or sending to this particular nginx, this service object will be taken care of. This service object will be taken care of. Sorry, will be taken care of sending the request to these pods in the background, the 5 containers, like that. Like that, the service object will work. Guys. Clear? Then, so this is about horizontal for autoscaler, and this is about the service object with the core DNS, how it is going to work. Right. So now in our Kubernetes deployments, how the deployments are going to happen on the our Kubernetes cluster, right? So now the deployments will be different types. So if we are going to talk about the deployments, so then from the Kubernetes, the deployments can be categorized into 4 to 5 types. So the in the 4 to 5 types, the one is rolling update. So this is our interview question for us. What are the deployment strategies on the Kubernetes side? Right now, the strategies, right? What kind of deployment strategy are you guys are following in the current project or in your experience? So now here, first one is the rolling update. That is the default one. Yesterday we have seen how to update and how to revert the changes. So there, the default one only we have used. That is nothing but the rolling update is the deployment strategy. Right. So how the rolling update will be works? Like we have seen, right? So like as I said, it will it will create a new set there. Once the new set is created, it will delete the old set, old part. Like that. Once the new one comes, it will delete the old one. Like that is going to match both the new set and old set, and it will maintain the high availability. Then once all the new sets are created, then automatically the old will be gone. Will be gone means it will be go to the buffer area. Right. So likewise, so if I have the version 1, 2, then here version 1 will be deleted and the new parts will be created. So that finally all the version 1 will be deleted, all the version 2 will be come to the picture. The same method we have seen also. So what is the advantage and disadvantage from the rolling update? Version is slowly released across the instances. Right. If there are two, three, then that is fine. If there are hundreds of parts, then yes, it will go one by one page, right? So there, yes, you can see the slowness and convenient for the stateful applications. Basically, this rolling update strategy will be convenient for the stateful. Stateful means the containers are going to maintain the state. Basically, containers are stateless. So that is the reason we are going to create the volumes. The volumes will be mounted to the containers to maintain the state. But here I mentioned like stateful means what will happen. Na? So usually if it is my server, then here whatever the containers I'm creating, these containers are stateless. Their guys are not maintaining any state. If the container is gone, we are going to lose the data. So that is the reason what we'll do. We are going to create the volumes. Right? The volume will be mounted to your containers so that the data can be maintained on the volume. Even though I lose the container, when I created a new container, then I will mount the container to this volume so that your data can be persistent. You can see the data. This is the stateless. To maintain the state for the stateless, this is the concept of volume. When we are going to when we are going to discuss about the stateful sets, now the stateful sets are nothing but each container are going to have their own volumes, not like this. That's what the stateful set means. Each container will be having their own state. Like this guy will be having their own volume, this guy will be having their own volume. That's what the stateful. Again, if you want to maintain the stateful, yes, you need to do the configurations. Not by default, the container by default containers are not going to have any capable of holding the data. That is for sure. So if you want to maintain the stateless or stateful data maintenance, if I'm going to talk about data maintenance, if you want to maintain the data of the stateless container or stateful container, then the approach will be varied. For the stateless containers, if you want to maintain the data, you have to create the volumes. For the stateful containers, you want to maintain the volumes. For each container, you have to attach the volumes. For each container, you have to attach the volumes. Now, each container will be having their own space, own volume. That's what the stateful sets. Okay, so it's kind of a concept in our Kubernetes. So now here that for the stateful applications, this rolling strategy will be the convenient. Now here from the con side, rollout, rollback can take time. Yes, if it is version is slowly released, means slowly it will go to update when there was hundreds huge amount of containers. Now here supporting multiple APIs is hard, not difficult, not is saying like it is hard means you can maintain it, but some more groundwork has to be done. Multiple APIs if you want to maintain. No control, you cannot control the traffic on the rolling update strategy, right? If the requests are coming when you are updating in the background, when you are updating in the background, if the requests are coming here, right? So the request can go here, version 1, or the request can go to the version 2 also. You cannot control it. That's for the no control. But it's not a problem, right? So maybe out of 100 people, there can be a choice of 60 to 70% people are still accessing the old version. The 30% people will be accessing the new version. But later on, after 5 seconds or 5 minutes of time, the other people also will get the new features. That's not a problem. But yes, the thing is, you cannot, if you want to deploy the entire version 2 at a time, not like slowly, page by page. By that time, this is the problem. Like you cannot control it. Right. So in the rolling update side, these are the pros and cons. If you want to do the rolling update deployment strategy. Okay, fine. Okay, fine. This is the rolling update. Then where I need to configure it. Yesterday I have told you like this is the default, right? So this is the default rolling update strategy, which is going to take care. So where this configuration has to be done. Let's see. So let me go to the cluster again. kubectl rollout stray deploy nginx. There were two deployments. kubectl -2 -revision equal to 2. roller history deployment ABC. kubectl where is the deployment section. Rollout scale auto scale kubectl rollout -help status history undo. Let's see rollout status. So let's check this out. Rollout you have only options of history, pause, resume status, and undo. Describe deploy engines. I'm going to remove this stuff. Enter. So go here. Correct. Yeah. So we can find this information in the deployment object. Deployment object. If we try to describe the deployment object, there you can find here strategy type rolling update. Right. So now here how to the strategy is the rolling update, that is nothing but the default. The deployment strategy, one is the rolling update, right? So that is the default. I never mentioned. I did not bother about it. Automatically it's taken the rolling update if you are not mentioning it. Then here the rolling update strategy how to be worked. Like it can be worked like as I said, it can be like one container will be created. When the one container is created, the old one will be deleted. Like well, likewise, the instances count are the percentage wise, right? So 20%, 25%. Like so there are 100 means 25 content will be set. It will take with a set wise. 25% will be down, 25% will be created. Like that, you can take the percentage wise or you can take it as a count wise. But in the background, the story will be the same. Right? It will one new one will be created, old one will be terminated. Like that. Right. So now let's see here an example. Like anyway, we have seen that one also. But one more time, we'll try to understand the deployment strategies. So clone this repository into your local to see the use case. So let's clone the repository. This is the repository we have cloned. Go to the rolling update directory and deploy app v1.yaml file. Okay. So cd Kubernets. Deployment strategy. Go to this one. Here you can see rolling update. Go to the rolling update. You can see there are two deployment files are there. Let me open the first file. What is there inside the first file? Service. So here yes. Right. So if you guys have, remember in our yesterday practice, we have created a deployment file and we have created a service file. Right. So deployment file will be taken care of deploying the parts, deploying the deployment object, and deploying the containers. Sorry, containers, parts, and replicas. Right. So all the three will be taken care of by deployment, and the service object creation will be taken care of by this service error table file. Right. So now here in our Kubernetes, this deployment process, either you can have multiple files based on the objects. Objects means pods, deployments, service, replica controllers, like that. So based on the objects, You can create their own files, or you can club together. You can take a single file. On the single file, you can place all the object details one by one, so that one file will be enough to deploy all of your components for the particular app or for the particular module. Right. So now here this deployment file and the service file are belongs to only one module, my sample container. Right. So here I'm trying to create Apache. Right. So now both will belong for the Apache deployment only. So now here, if you think like multiple files maintained is somewhat difficult, then what you can do here is, instead of having multiple files, you can place both the service and the deployment together in single file, in a single file. Right? That is also possible. That is also acceptable. Right. So now here, that's what here showing. Now let me go to the path ls. Now open the cat app v1.yaml file. So here you can observe the first one. Right. So now this is the separation. So now this is nothing but it is a representation of this part is completed, and a new part is going to starting here for the YAML. In the YAML, this is the representation. So now here, this is the service object details. So now here you can see service, right? Then this is the service metadata, service label name, right? As I said, the service label name and the pod label name are matched, then your core DNS will update the endpoint of the service or nothing but adding the pods into the service object. And what are the two? This is the one. Service label name and your container label name, pod label name. Both should be matched. Right? This is the concept here. So now here, service my app and service name, and this is the service label name, and my type is node port. If I want to access into the outer world, HTTP port. I'm going to use this is internal, and if I don't mention any port number of the node port, by default one port will be allocated, and the target port will be HTTP, and this is the selector. That's it, right? You know. Then the deployment. So in the deployment, you can see API version, then the deployment, then this is the metadata, right? Deployment identification, and 5 replicas I am looking for, and this is the selector section. From that you can see your container details. That this is not the content. This is about the deployment details, and this spec is for the deployment details, and this spec is for the container details. Now in the spec we have mentioned like I want 5 replicas, and this is my matching labels. My matching labels. Then in the template I'm going to mention like my app will be having the version so and so. Right, as I said, we can fetch the information by using the details. If you have if you provide multiple details, so that you can fetch with the help of app, you can fetch with the help of version, like that, when you want something on the data side. So then container side, my container name is app, and this is the content, some image, right? So whatever the image may be, fine, forget about this is the code. And the ports here we are using content port 8080 internally, and the probe. So these are something like health probes. Actually, we'll discuss about the health probes a little later. The 8086, and here the environment values, environment variables, right? So in our Docker, if you want to pass the environment variables, what we have used, Docker run -e, then the variable name, password equals so and so, or in the compose file, Docker in the compose file, we have mentioned env section. In the env section we have added the environment variables. Like that here also, when you want to pass any environment variables to the pods. Pods are nothing but the containers. So if you want to send any environment variables to the pods, then this is the section. env the section, which has to be defined under the containers, nothing but under your deployment object only, right? Because into the server only you have to push the data, or you want to place the data. So everything has to be defined in the container section only. So now here this particular application is having an environment variable, nothing but version, and for the version the value is given as 1.0.0, injecting the environment variable. env section. Right. So this liveness probes, readiness probes. After the deployment strategy, we'll discuss about this thing. Right. So let's forget about this part right now. Then this is our deployment object. Just I'm trying to deploy some code with the version 1.0.0 with the version 1.0.0. That's it, which is running on the port 8080. So then deploy it. Right. So now to deploy it, what you need to do, just run the kubectl apply command. Right. So let's run the kubectl apply, nothing but deploy this piece of code into the cluster. So kubectl apply -f v1.yaml file. Kubectl get all. Now you can see there are 5 pods are created because I mentioned 5 replicas. I record 5 replicas. This is my previous one, Nginx. Okay, forget about the Nginx. We are not bothering about the Nginx. This is a separate service. Now here, my application is launched with the 5 pods. Now here, see, it is not at ready state. Now let's try to run the command again. Now all the 5 are ready. Right now this is for my app, and the port is allocated 32230. 5 out of 5 are ready. 5. Right. So now here, forget about this thing. HPA, horizontal pod autoscaler. I am not configured the HPA for this deployment. This HPA is deployed configured only for Nginx. So this is the Nginx service details. Okay, forget about this thing. We are not on this topic. So now here, I have my 5 pods are running. Now let's go to the browser and try to hit the URL. So now the port number is 32230. 32230. My application is running with the version 1.0.0. From where this data is picked up? From the environment variable. This is the environment variable, right? From the server, it picked up the environment variable. So where the environment variable is configured? In the environment section. This is the stuff. This version is picked this value from that. Okay, fine. So now here, my application is running with the version 1.0.0. So now I want to upgrade. I want to upgrade the version 2.0. You can see here version 1.0.0 which is passed at the deployment file. Just now I have shown you. You can observe the deployment strategy section with the properties in the deployment file. Right? So in the deployment file, if I open the deployment file, anywhere they mention that this is a rolling update. Am I right? kubectl get pods, get deploy, and take the my app kubectl describe deploy. Right. So in the deployment file, nothing is mentioned, but still we can say the deployment is the rolling update. As I said, it's the default one. If you don't mention also, by default the cluster will be taken care of the deployment strategy as a rolling update. So now let's try to upgrade the version. Now try to deploy the version 2 file and observe the deployments of parts in another window. Right, so here I have the other window. Sudo -i clear kubectl get parts. Right, so I want to monitor it, the parts creation and other stuff. -w, so that it will be in the watch page. So now the 5 parts are running with the version 1. So now here what I am going to do, I am going to deploy the version 2. Cat app v2.yaml file. Just try to understand. So here this is the same only, no difference. So here you can see app version is changed to 2.0 and our environment variable value changed to 2.0. That's it. The same only. Nothing difference here. And just we are pointing to the 2 and here the replicas are 5. The same. Except the version, rest of the things are same. Just I want to upgrade it. So now here let's apply it. kubectl apply -f app v2. Right now see one container creating 25%. It's not like a one by one container. It is going to work with the 25% because there the threshold value there by default is on the percentage base, right? So here see creating and terminating, creating and the terminating, like on the percentage basis, it is going to create and terminate. But here, if you try to hit the URLs, you are not going to see any downtime, right? My version is upgrading in the background, but you are not going to see any downtime. Still, you can access the application. That's what the beauty of our cluster. Right, so here terminating and running. So let me open this one in incognito window and try to hit version 2. Sometimes the browser catches. Our web browser catches will be stored the old values. That is the reason if I hit the thing also, it is showing version 1.0.1 only. So to handle these issues, open your incognito, which is not going to store any caches. It is not going to store any browser caches or something. Always just try to load freshly. So that is the reason I went to incognito. There you can see now it's updated to the version 2.0. Right. So now you can see without any downtime, our container means your version is updated. So now here get kubectl get parts. You can see all the 5 are running. kubectl get parts. All the 5 are running. Just for to confirmation, that's it. kubectl describe parts and the part name. You can observe it here. Labels are version 2 mapped with version 2, the latest one. The same image, it is pointed to version 2.0. Right. So updated with the version 2.0. So now this is the version 2.0, our environment variable. Version 2.0. Right. So now here, this is what the rolling updates. Right. Now we have some understanding how this rolling update is going to work. right? It will delete the parts, it will create the part, this is the part, is going to balance both together. But in the background, we are not going to see any downtime of the application, but it is a slow process. That's it. So now let's go and see the second deployment strategy. One pod is going to create with the latest and one pod is going to terminate. During the deployment process, if you try to access the app, you'll see the older version. Once all the parts are up to the new version, then only you can get the latest. Okay, so I have given the wrong statement, you guys. So not like 90%, the rolling update will be taken care of the new version only once all the parts are up and running. Not like the basis, the distribution basis. Right. So now rollback. We have seen that, right? If you want to roll back to the previous state, roll back, undo deployment so that it will go to the previous stage. That is, we have seen also, right? Rolling back, we know. So then the second one, recreate. In the deployment strategy, the second one is recreate, right? So what the recreate will do? Application state entirely renewed. That is what the pro advantage side. Now the con side, downtime, that depends on both the shutdown and boot duration of the application. See, there is a downtime. So what the recreate will do, when you are trying to update, the versions by using recreate deployment strategy, so then what it will do here is, suppose this is my version 1 parts and these are my version 2 parts. Version 1, version 1, version 2, version 2. Right. So now, right, this is the latest, sorry, not the latest, this is the currently running version 1 and this is the latest version. Right. In the rolling update strategy, what happened? It will delete, it will create, it will delete, it will create. Once all the parts are up, then the traffic will be routed without any downtime. But here what will happen? When I'm trying to update the version 2 with the recreate, the deployment strategy recreate, then first it will start terminating all the containers. Terminating all the containers. Then we'll start creating the new containers with the version. So now in the process of termination and the creation, the time, whatever the time is there between the process of deletion and the creation, this time will be the delay, nothing but the downtime. Because once these parts are terminated, then it will start creating the parts. So now after the termination and creation, this can be there we can observe some delay, some downtime. That's what here the recreate. Downtime depends on the both the shutdown and creation, right? How much time, right? Maybe if there are very very lightweight, hardly we can see seconds of the downtime. If somewhat, then you are going to see 50 seconds, 1 minute, not 1 minute, even though like 30 seconds, 40 seconds, something like that. Right? That is what the recreate. Let's see. So let me go to here, kubectl get all. I am deleting the existing one, the rolling update strategy one. Kubectl delete -f. That means whatever the deployment files are there in the, I need to go to the rolling update one. Go to the rolling update, and here whatever the deployment files you have applied by using these files, I want to delete those components. So for that, what you can do, give detail delete. Instead of apply, give the delete, then -f dot. So it will go to each and every file. In the file, what are the components are there, like the deployment service, what are the components are, those will be deleted. This is the another way, deleting of the components. Usually, how we are deleting, kubectl delete deploy, kubectl delete service, kubectl delete pod, like that. So now here I can give the file name so that whatever the components, objects are there inside the file, it will be taken care of the deletion. Your cluster will be. deleted. So from one file it got deleted. Both are having the same component. That is the reason it is not finding the on the second file. Anyway, that is fine for me. Now kubectl get all. I should see only the Nginx one, not the my app one. Get all. Right? Only the Nginx one you can observe here. Right? My app one is gone. So now here what I'm going to do, let me come back to the deployment strategy folder, then go to the recreate. Again, we have two files here, cat app v1.yaml file. So now here you can see strategy. If you not mention the strategy now in the deployment, right? If you are not mention the strategy, then what will happen? It will go to the default rolling update only. Right. So now here I want to change it to the second type of the deployment strategy called recreate. Right. So that is the reason you can see the property called strategy, then the property I have mentioned as recreate. So now the rest of the story will be the same. Here taking the three replicas and the version 1.0.0, same core, same thing, same nothing, no difference here. The only thing is the strategy type is changed. So now kubectl apply -f app v1.yaml file. The service and deployments are created. kubectl get pods. Now you can see there are three pods will be created in the background for this particular app. Three pods with the name my app, kubectl get all, so that I can see all the details again. I want to see the service object details. Now where is the service here? Service and my app, and the node port is 32139. So now this is gone. Now you cannot access with this port number because I have deleted it. So now 32139 running with version 1.0.0. This is our incognito 32139. No buffer, no caching. That version 1.0. So now update. We can observe three pods are created. Now try to access the application in the node port. Fine. Done. Now deploy the version 2.0 and observe the deployment process. Okay. Right. So now let's see. So take the two windows again. So kubectl get pods -w. Just I want to watch it. Right, three pods are running in the back. Now let's try to apply kubectl apply -f app version 2. Right, we are in the recreate folder. Right, fine. Now see, all are terminating at a time, not like one by one. Now here, if I try to hit it, so there you can see the delay. Right, so it is taking some delay. Sometimes we are going to see unable to read, something like that also, because it will delete at a time and will start creating at a time. Right, so now it's back. So see the delay you can observe here, there, right? So version 2, now you can see the version 2 came back because it got created running. So like that, the recreate strategy will work on nothing but terminate at a time and create at a time. QCTL get pods. Now the three are running for my app. So here it is changed to version 2.0. So this is the recreate strategy. Then the third one, blue-green deployments. I think you heard about this blue-green deployments. And so the blue-green deployments are nothing but we are going to have two sets. Nothing but we are going to have two environments. We are going to run two environments parallelly. Until now, we are having only one environment, one cluster, like this. So now here in the blue-green deployment, we are going to have one environment, something like that, and one more environment, something like that. So now we are going to call something like this, blue and green. So now here my pods will be running with version 1. With version 1. So all the traffic will be hit to this cluster, to the version 1. So when in the background on the other environment, we will be working for version 2. Version 2. Right. So now here, this is a separate environment which is running with version 1. Now people are utilizing the environment. Now in the second environment, we'll be working for the new latest changes, latest updates or whatever it may be, features, what it may be, like it's a version 2. So once this is ready, then simply we are going to route the traffic from the blue to green, like this. Switching the traffic, that's it. We are not going to delete or create something like that. Right? In the blue, again, the version 1 will be running something same. Now the green will be having the version 2. Now we are the traffic will be routed from one environment to another environment. Now people are start utilizing the version 2. Suppose something is not working, something is fishy. Now simply what you will do, you are going to point to the version 1. You will go to the blue deployment, blue environment. That's it. Likewise, you can divert it. Here the thing is just only diverting the traffic from one environment to another environment. That's it. That's what the blue-green deployment actually. So suppose it is working fine. Now what will happen here? We will start working for the latest features like version 3 here. Now the new deployment will be taken care on the blue environment, nothing but version 3. Once the version 3 is ready, then the traffic will be routed to version 3, then version 2 will be there. Once it is good, then we will start working on developing the features on that particular environment like that. This is what the blue green actually. So now let's go to our strategy. Instant rollout and rollback, right? Instant only because just simply our job is to switch the traffic instantly, right? Just you are going to route the traffic from here to there. That's it. That's what the advantage here. Instant. Avoid versioning issues. Change the entire cluster state in one go. Right? Versioning issue means that here the version 1 is there, version 2 is no. You don't bother about it simply because the set will be working in there in the separate environment. So you don't need to focus on the environment versions or something. Change the entire cluster. Change the entire cluster. The entire cluster you are going to change it. Right, so now require double the resources. Here the problem is, yes, this is fine, right? Instantly you can change the cluster so that you can get the previous state back without any downtime and without any consuming of the time. Consuming of the time in the sense you don't require to wait for 5 minutes or 2 minutes, something like that, instantly. But the con is you need to double your resources, right? Yes, double the resources. This is one cluster and this is one more cluster. Two clusters I need to maintain. Obviously, the cost will be high. Proper testing should be done. Yes, because you are simply routing the traffic version 1 to version 2. If you don't done the testing properly, then it is a failure. Proper testing is required. Handling stateful applications, right? If there are stateful applications are there, means every country having their own data, then the stateful application handling somewhat difficult. Here, the blueprint deployment. While changing, it may crash out. You can see some kind of difficulties while switching the environments. Right. So now here to see the blue-green deployments here, we are not going to create multiple clusters. Simply on the same cluster only, we will try to see this feature, blue-green deployment. Right. For that, what here they're saying is, go to the Google deployment directory, then deploy both the files at a time. It will create 3 replicas for version 1 and 3 replicas for version 2. Right, so let me go here. So I'm creating the existing objects. So I went to recreate. Then I'm going to delete the components whatever we are deployed right now. kubectl delete -f dot take all the files. kubectl get all. Only yes, terminating. These are in the process. Only engine should be there. Right. So let's run the command line. Now all are gone. Only engine I can see. Right. So now here let me go to the other strategy called blue green. So come back and go to blue green. CD blue green LS. Okay, so single service. In the single service file, you can see there are 2 files. Open the app version 1. Same story only, no difference. Everything is same. Replicas are 3. Earlier we are taking 5, now we are taking 3. The same. But here, if you observe here, there is no deployment strategy type. Right. So now here, by default, rolling update, recreate are the deployment strategy which is providing the Kubernetes. So the default, that is the reason we can mention like I need the rolling update or I need the recreate. But this blue green and other stuff is not the Kubernetes default stuff. We are going to set up from our end. So that is the reason we are not going to mention any kind of rolling strategy here. So we are going to do it forcefully. Means we are going to override the thing with our own strategy, own setup. Right. So then the second one cat, the same files only, no difference, just only the replicas are changed. That's it. This is the app to version 2 and here 5. Right. So now here let's try to deploy both kubectl apply -f. Right here I'm not going to mention the file name because I want to deploy both the files together. I'm going to give the dot, ask the system to take all the files from the current directory. What is the current directory? Single service. The current directory have 2 files. Take all the files, dot, enter. Right, so here you can say service is created and two deployments are created, right? So because there are two deployments, one is for the version 1 and two, the second one is for the version 2. 336, we are going to say kubectl get pods, 3 for version 1 and 3 for version 2. It will create 3 replicas for version 1, it will create the 3 replicas for version 2. We can observe that one. Right, so now try to access it, try to access the application with the node port. kubectl get svc. What is the port here allocated? 32544. Let's go to the browser. 32544. I can access only the version 1. Even though I have 6 parts, out of the 6, 3 are running with version 2 and 3 are running with the version 2. Yes, but right, but only one service object. So now here, why the version 1 is hitting, right? There is a chance of version 2 also be hitted because equally parts are running. Right now here the thing is, if you remember again, service object. In the service object, what are the endpoints are updated, correct? So the service object is the one is going to play the load balancer inside the cluster. So when you are trying to hit the sender request, now the request will go to service object. So now whatever the endpoints are updated by the core DNS, updated by the core DNS. So the service object will send the traffic to the only the parts. So now here, if you observe here, the version 1 means the version 1 parts are updated in the service object, not the version 2. That is the reason we are hitting the version 1 only. Let's see. kubectl get svc via kubectl describe svc via, right? Perfect. You can see here there are only 3 parts are mapped, even though there are six what is called 6 parts are running, but in the background 3 parts are updated by the coordinates because the label names, whatever the label names we are passing, right? The same story. When the pod label name is matched with the service label name, then your code DNS will be updated the endpoints with the pod IPs and the port number. That's here my label we have given as a version 1. Version 1 selector my app. From the my app I want to have the version 1. So that is the reason whatever the parts are running with the version 1, those are mapped with the selector, the service object. Clear? So now here I want to switch to the, now you can take this as a blue deployment, blue green deployment. If I take this one as a blue green deployment, so now v1 is the blue and v2 set is the green. There are 6 contents are running, out of 3 parts are running in a separate, you can assume something like that. So now the version 1 is running in a separate set and version 2 is running in a separate set. So now your service object is updated with the version 1. Now I want to switch the traffic. Right? There is a separate set is running in the background with the version 2, 3 parts. 3 for version 1 and 3 for version 2. So now here my service object is mapped with the version 1 just now, right? So now what I need to route the traffic to where right, to the version 2 because the version 2 is also ready. It is running in a separate cluster. Assume it's running in a separate cluster. That's now I need to switch it. Right? So how to switch it? Once the testing is complete on the V2 means the V2 is ready. Once the V2 is ready, then switch the load to the V2. Right. So now here by using the label, right? Because your code DNS will try to match with the labels. So now here just you need to update the label. So how to update the labels? So this is what the command kubectl patch service. What is the service? My app. And the my app service I want -p for nothing but the patching. So what patch you want to do under the specification? There is a selector, another selector, there is a version, another version. What are the value there? Override that value with this new value. Let me go and see ls cat open any file. This is my deployment, which is running with my web and version 1.0.0. And this is my service, which is trying to map with my app version 1.0.0. So, right, so that is the reason these three parts are mapped with the service object for the version 1.0.0. So now I need to overwrite it. To overwrite the version 1.0.0 to version 2.0 for the service object, so that now the traffic will be routed to the version 2, not this version 1. Right. So now to change it, this is the command. So just run the command. So I'm trying to patch the service object, the version 1.0 to 1.0 as the version 2.0. So go here and run the command. You can see my app is patched. So now here kubectl get svc. Now kubectl describe svc my app. So now here your app should be pointed to version 2. Right. So now your selector is mapped with the version 2.0.0. So now again you can see the version 2.0 parts are mapped to the service object. Right. So now here let's try to access. Perfect. Right. It switched to version 2.0. Right. So likewise your blue-green deployment will be works. So nothing but you will be running two environments parallelly. Two environments. There on the environment one set will be running, on the second environment one more set will be running. Now the traffic as we switch to there are here, there are here. That's it. Based on the use case. Failures. Simply what you will do, you will switch back to the version 1. Simple by running the command again. Right. So here if I run the command again, like kubectl patch. Here I will give version 1. That's it. So now again the traffic will be routed to the version 1 set. Right guys, this is what the blue-green deployment, and the final one. Right, you can change it to version 1 also. Something like something like this. Open a new window and try to get it. Still just showing version 1 only. Sometimes the browser can, not the updates issues, the browser issues actually. Want to revert the system version 1. Change the not after, close the browser and start and check. kubectl get svc 32544. Now you can see it is pointing to version 1 only. So it's the browser issue, not the deployment issue. So now here the next one is to the last one, canary deployments. Right. So now here the canary deployment, what the canary deployment, what are the advantages and disadvantages? Versions are released for the subset of users, so that convenient for error rate and performance monitoring. Fast rollback. Cons, slow rollout. Fine-tuned traffic distribution can be expensive. Okay, fine. What the canary will do here? So now here the canary deployment is nothing like. So this is my cluster, and my cluster now will suppose assume running the application with 4 pods. These are all version 1. Okay. So now here the version 2 I want to deploy the new version. So now here in the previous stages, if you observe in the previous stages, previous strategy types, deployment strategy types, rolling update, recreate, locate, everywhere the complete set for the version 2. If I take the rolling update, so once the new set of version 2 is ready, then the traffic will be routed. Means the complete like subset means 10 parts or 100 parts. Without downtime, they are going to create the containers in the backend parts. Once all the parts are ready, then the traffic will be routed. Complete set. Here the word is complete set. For the recreate also the same. Once all the existing are terminated, then the new one will be created, then the traffic will be sent to the new one. Complete set again here also. For the Brooklyn also the same process, right? But here the thing is you are not going to terminate any container, simply you are going to switch it. But here also the complete set. On my blue environment also the 100 of 10 parts will be there. On my green also 100 of 10 parts will be there. The complete set. But in the canary, you are not going to have the complete set. So what you will do, you are going to release slowly. Nothing but in the subset forms. Right. So now here what I will do, I will update for the subset of users. So now suppose there are like assume is like a kind of assumption. Like here there are 100 users are using my application. Now here 100 users means 25, 25, 25, 25. So now what I will do, now the version 1 I am going to release for the subset of users, 25 users. So now 75 users are going to still access the version 1 out of 100. The 25 users are going to access the version 2. Subset will be released. Now I will monitor if the users are facing any issues with the new deployment. Right. So now if out of 25 users, 10 users are raises a concern like I am not able to access the page properly, or something is not displaying, or something is not working properly, means we are what is called, sorry, uh, uh, sorry guys. So yeah, so now here 25 users will be accessing the version 2, then the 75 people still accessing the version 1 only. Now we are going to monitor the 25 users the response. So if out of 25 the 10 people are raising concern like I am not, the place is something like glitchy or something, some XYZ concern they have raised, means your deployment, your new version is not the proper one. Out of 25, 10 people are raising concern means it's the issue, it's a bug for us. So now what I need to do, simply I need to revert the 25 users to the back. That's it. That's what the advantage here. Rolling out can be done easily. Fast rollback, right? Because only the 25 users, only the one set have released issues, then simply reverted back, right? Still, that's what the rolling easily. Then the thing is version is for the subset of users like that. Convenient for error rate and performance monitoring. Yes, correct, right? So when you deploy for the 25 users, you can monitor it, the application performance, issues, and everything. Now, if you okay, fine, out of 25, no one is raising any concerns. But then what you will do? You are going to deploy one more subset of users. So now here your users will become 50 users. Here the 50 users will be accessed to the version 1 like that. So now 50-50 like that. You are going to release the set by set. Then you are going to monitor it. Once if you see no issue, then finally you are going to go for the 100%. So that's what the canary deployment subset of users we are going to release it. So to see this use case, go to our cluster. Right. So now here right. So now here let's delete the existing one. kubectl. I will go to the folder, then from that I will delete it. cd Kubernets deployment blue green kubectl delete -f dot. Okay. Single service kubectl delete -f dot. And now kubectl get all. You can see only the nginx. We are good. So now come back and come back from the blue green, and here you can see the canary one. Go to the canary, go to the native, create app v1, 5 replicas are there. Right, 5 replicas are there for my version 1, and cat app v2, and here I have 1 replica. Okay, so now here what I will do. Right, so first I will deploy the app v1 kubectl apply -f app v1.yaml file. kubectl get all. Still are creating. 5 already. Now the port is 31460. Version 1. Right, so now here X application with the node port. Now scale down the version 1 to 2. Okay, right, so now here what I'm trying to do here is I have total 5 sets, 5 parts are running for the version 1. Right, so now we can observe here 5 parts are running. So now here I will try to deploy the version 2. Then I will match with the 5. So now what I will do, subsets means out of 5 I will run with the some set with the existing version, and some set like 2 or 3 with the version 2, right? Right. So out of 5, 3 will be running with the version 1 and 2 will be running with the version 2. So that the people who are trying to hit the service, now some people will hit the version 1 and majority of the people with the version 1 and lower count of people are going to hit the version 2, right? Because we are maintaining the 5 set. Out of the 5 set, like 4 will be with version 1 or 1 will be the version 2, or like then 3 for the version 1 and 2 for the version 2, and later on 2 for the version 1, 3 for the version 2, then 1 for the version 1, 4 for the version 2, then finally 5 for the version 2. Like that, sets wise the deployments are going to happen. So for that, what I need to do, simple. I need to, now the all 5 are running with the version 1. Now what I will do, I will scale down. I will scale down my version 1 to some lower count from the 5 to 3 or 5 to 4. Then the rest I am going to fill with the version 2. The rest means whatever out of 5. If I scale down to 4, then 1 I am going to fill it. If I scroll down to 3, 2 I am going to fill it. So how we are going to do? With the help of scale, with the help of scale option, right? So now here, let's scale down. Right, so now see this use case. If I, right, so now here, if I make it 2 to 3, then you need to continue hit the server. Then like because out of 100 request, there is a chance of 80 will go to the version 1 and 20 will go to version 2. So that is the reason. So what I will do, I will try to decrease 5 to 1 and 4 for the version 2, so that I can see the thing fastly. Otherwise, you have to hit something like that. The request has to pass something like that. So now here, what I will do, I will scale down my app 1 to kubectl get parts. I can see 2. Even I will decrease to 1 instead of 2 also. Terminating now, we can see only version 1 will be running with the still in terminating. Right, so now here only one part is running. Even though right now only the version 1 is there, so that is it will obviously go to version 1. So now here kubectl, now the next one is apply the version 2. Kubectl apply -f version 2.yaml. Now kubectl get parts. Right, so here 2 parts are running because in my app 2 I have given the replica count as 1. So that is the reason it is running with version 2. So now kubectl get svc. Kubectl describe describe svc my app. See, two parts are mapped. Two parts are mapped. One is my version 1 and 2. Second one is the version 2. Right. So now here I am going to scale up my version 2 to 4 so that the desired state will become 5. See, now your service is updated with the 5. 1, 2, 3. Still one more is coming, means it is going to have total 5. 2, right? 3 plus 2, 5. Now the 5 set will be running with 4 will be running with version 1, 2, 1 will be running with version 2. So now here let's try to hit the application. It came to version 2. If I hit something like that, sometime after so many requests, there is a chance of one request will go to the version 1. Right? So this is the problem. That is the reason I have given as a 4 actually. Right? So in the real time, right, out of 100 users, 20 will be go to 25 will go to the version 1. So after hitting up so many requests, there is a chance of it will go to version 1 also. Because version 1 and version 2 running parallelly, right? 4 majority of will be running with the version 2 and lower count will be running with the version 1. Right, so you can see my request went to the version 1. So like that. So like that, this canary deployment will be works. So now here the canary is nothing but releasing the version for set of users for the set of users. Right, this is the deployment strategy guys. So in our Kubernetes, so there are different deployment strategies: rolling update, recreate, blue green, canary, blue green, recreate, rolling update. Right. This is one of our entry questions. Right. So let's take a small break here. Then we'll come back and we'll see the monitoring side of the Kubernetes, how to monitor our pods and other stuff. Okay.
Okay.
Yeah. Thank you. Thank you,
This
Parag.
conference will
So
now
now
be recorded.
we need to go and verify where what is the problem, where the problem is occurring, like that. So that will be resolved very easily with the help of monitoring tools. Otherwise, you need to go each and every pod, open the logs and verify the line by line, and see what is the issue. If you're able to understand, that is fine. If you're not able to understand, you need to go deeper. You need to go in somewhat deeper, and you need to understand more. Like now, the part is eliminated with the help of monitoring. It will show you the details actually. Right. So now here the Kubernetes cluster can be monitored with different monitoring tools. So now here, the different monitoring tools are like you can use the New Relic. You can use the New Relic to monitor your cluster parts on the parts, the utilization of the parts. And the New Relic has a features of not only infra monitoring, right? There, the monitoring can be divided into multiple parts. One is infrastructure monitoring, and the second one is application monitoring. Right, so now here for the infrastructure monitoring means like on the servers, the CPU utilization, networking, hard disk space utilization, these things. From the monitoring, application monitoring side, your services, your apps, the apps will be monitored, right? How the apps are working, what is the performance of the app, how faster it is responding. Such kind of monitoring can perform. So New Relic is a monitoring tool that is a paid tool actually, not the open source. So then that paid tool you can monitor both infra as well as our application also. I will show you my project, maybe not today, in our next class, like the monitoring part. When we are in the monitoring, I will show you. So now here from the open source side, right? So from the open source side, what are the tools are available for us to monitor our Kubernetes cluster? So there you can have Prometheus, Grafana are the monitoring tools from the open source available. On the open source side, you can have the tools called Prometheus, Grafana. Prometheus is a query kind of monitoring tool. Like you need to pass the queries and you'll get the results. Grafana is a graphical user monitoring, so that visualization will be there for us. Grafana. From the Prometheus side, you are not going to have any kind of visualization. Simply go and fetch the data and get the results, and that's it. Here you can have the dashboards. On the dashboards, you can see some graphical representation, the Grafana. Okay, let's see the Prometheus and Grafana by using both. how to capture, how to grab the details of the cluster. Right? So that monitoring also, the monitoring installation, right? You need to install the tools called Prometheus, Grafana, or whatever the monitoring tool you want to set up, you have to install on the servers. Right? So now in the cluster, if you want to set up the monitoring, you obviously you require to install the particular respective monitoring tools here. So now we'll go to the same structure, nothing but the repository here. So from that, I will go to the monitoring section now. Sudo -i ls. Now here you can see our Kubernetes folder, and here you can find a directory for the monitoring. CD monitoring. Okay. Okay. Before going to that, I will try to explain this one more concept. Let's stop this one for a couple of minutes or so. So let me go back to our deployment strategies. Go to any folder, open any file, this. This is the section which I forgot to explain this. So right, there is a probes called liveness readiness probes. Liveness readiness probes. So what the liveness and readiness probes are going to do in our cluster. So usually what will happen? So when I'm going to launch my applications, right? My application will be having the modules. Now each module will be deployed as a container. Correct? If I take an example of our banking, credit card is a module, it is a separate container. Credit card is a module, it is a separate online banking, like that. So now here, when you deploy the features onto the modules wise, like I have added a feature into the debit card module. So now I am going to deploy the debit card module only, not the entire pack. That's what advantage on the microservice side. So now when I deploy the debit card module, means the latest features. So now here we are going to verify is the cluster is having any issues to launch the pod with the new version. There are a number of reasons will be there to create the pod. While creating the pod, the issues can be arise so that the pod is not going to create. So now what will happen? Your deployment will be hanged out there. Your deployment, right? So if it is a recreate, if suppose if the deployment strategy is a recreate, assume, then what will happen? It will delete the existing one first. Means your existing version will be gone. Now the new one is going to launch. While creating the container, it is having some issues. Your cluster is having issues. It is not able to launch your container. Now what will happen? The customers are facing the downtime of the issue of your application, right? So it should not be like that. It should not be like that, right? So now here you have to take care of those things also. Otherwise, your application will be down for some time until unless you monitor or until unless you get the notification that that application is not accessible. Okay. So now here there the probes comes into the picture, readiness and liveness probes. So now what these probes will do, it will monitor, it will verify whether the container is up and running or not. If the container is not up, then it is not going to take any action on the existing versions. The versions will be up and running only until unless the probes got the clear sheet, the clearance, the container is ready. So that's what the liveness and readiness probes. So now here we are going to verify your container is running. Container means here the pod. Your pod is up or not, nothing but the readiness probe. Container is up or not, the readiness probe. Now suppose your container is up, your pod is up, but whatever the service we are trying to run inside the container, that is not active, right? So now in our example nginx, Now my Nginx container is running, but I'm not able to receive the Nginx. I am not able to access the Nginx. Means Nginx is not running, but the container is running, like that, right? So now here your container is up, your service is up, your module is up, but the whatever the module, the application is there inside the server, nothing but the container, that is not up. That's what the liveness. So now there are two probes will be there, readiness and liveness probes. Nothing but you are going to check whether your container is up or not, readiness probe, and we are going to check the liveness probe is nothing but this particular service, the particular service whatever you have launched inside the container is running or not. So now this is my container. So inside the container, suppose I am running Jenkins application. So now what the readiness will do, whether this container is running or not, right? So now the container is up, fine, good. Now it will go and verify whether Jenkins is running or not, right? So if the Jenkins is not running, then your liveness probe will stop the deployment and it won't allow you to terminate the existing version, the liveness there, right? So now if it is up, if it is also up, then it will be allowed to delete the existing container, then the new one will be comes up, until unless the old one will be there. That's what the without any downtime of application, even though you are using different rolling strategies or deployment strategies, there you are going to see such kind of issues. So now the issues can be handled with the help of readiness and liveness probe. Those you have to place in your deployment strategy. Means, sorry, not in the deployment strategy, in the deployment files. That's what here. Liveness probe and readiness probe. Right. So here you are going to check the paths. Right. So now here, if I go to my container, if my Jenkins is running or not, how I am going to know? What I will do, I will hit DNS name or IP colon 8080. Correct. This is my URL. When I hit the URL, if I get the response means the application is up and running. Likewise, any application there will take the APIs, the API calls like get users, push users, something like that. Now the API we are going to hit. Then if the API is getting the response, and the response means yes, it is up and running. If you are not able to get the response means no, it is not up. That's what the validation we are going to check, the paths. Right. This is for the liveness, like the live path we are going to give something like this. This is the path we are going to give so that it will give you the details. Right. So how long, like periods of seconds, the interval every 5 seconds is going to verify until unless it is up. And in between the delay seconds, 5 seconds, 5 seconds, hit it, delay for five, then again 5 seconds, next 5 seconds, hit it, and this is the delay like that. Like that, you can give the seconds of time when the concurrent hitting has to be performed. Right. So this is what we are going to call as a liveness and readiness probes. So that you are going to make sure your pods are up and running, then only go for the action of take out the existing ones. Otherwise, don't take any actions. This is one thing, guys. So then go to the monitoring side. So now here, go to the monitoring directory, and from that monitoring directory, create a namespace. CD Kubernetes, CD monitoring. Go to the Prometheus, CD Kubernetes, Prometheus. There are different files are available. Cluster role, config map, Prometheus, Prometheus service, Prometheus ingress, something like that. Right. So here, create a namespace monitoring and deploy all the files. Role building namespace is not required, is going to apply on the cluster. So there is a deployment file called role. This role binding, what is called deployment file, is not required to deploy into the your namespace. It can be on the cluster side. Deploy the config file Prometheus deployment file, Prometheus service file, config file, deployment file, service file, deploy onto the namespace called your monitoring. If you have low configuration, then resource section from the deployment file. So in the deployment file, cat Prometheus deployment file. Yes, I think resource section is already deleted. Right? There is no resource section. Resource section is nothing but the limitations. Our CPU limitations, memory limitations. Right, fine. So now here this is pointed to monitoring namespace, and if I open the cat cluster role.yaml file, this is the role is nothing but for the authentication. It is not pointed to any namespace. And if I open cat config file, this config file, this is the configuration file. So go to here, it is pointed to the namespace monitor. So right means you don't require to segregate the files and deploy into the namespaces. Already in the files itself, we have mentioned on which namespace it has to be deployed and on which namespace this guys has to be deployed. Right. So simply what you can do here is the first thing, let's create a monitoring namespace. Guys, this is a lowercase. Here it becomes a capital M, it's a lowercase section. Because in the files we have mentioned as a lowercase namespace. So now you know how to create a namespace. kubectl create namespace monitoring. Namespace will be created. kubectl get namespace. Now you can see one more namespace is created 5 seconds back. Now deploy the files. Deploy all the files. But what I will do, kubectl get pods -n monitoring. Just I want to see any pods are deployed in this namespace or not. No, because just now only I have created this resource namespace, no resource. Now kubectl apply -f deploy all the files. All fields dot take all the files, deploy it. All are created. Now let's try to run the command again. Get pods monitoring. Now you can see deployment is created. And one more is here. There are a bunch of files are there. One is the deployment. This is you can observe here. The second one is the service. So kubectl get SVC, right? SVC is a short form of service. You can say Prometheus is deployed in the monitoring namespace Prometheus service, which is running with the 30,000 port number. And likewise, we have one more file, config. kubectl get config maps. You can say one config map is created. I will let you know what is the config map, guys. I will let you know. So then ingress cluster role, right? kubectl get pods. This is on the cluster level. It is going to deploy get pods -n -n cube Your system. Spelling is wrong because the slowness of system, the characters are jumbling. The system with the net. Queue control manager, scheduler, dashboard, metric server. This is something like custom role. So I think its role is not a pod. That is the reason it's not showing here. So QCTL. If you are not sure, then what you need to do, you need to simply run get all. Get all so that it is going to show us all the components. If you are not sure whether it is a pod or is a deployment or is a service or whatever it may be. These are the duplicate assets. These are the deployments. These are the nets, daemon sets. This is the service, metric server Kubernetes dashboard, and they are the pods, OTNS, metric server. So means the role is not here actually. The role is not deployed in the queue system. On the cluster level, it will be configured. Let's see. Let's try to give get all hyphen hyphen all namespaces. I would like to see hyphen hyphen all hyphen namespaces. This is monitoring. That is our deployment. We are not going to see anything here. Group system, daemons, group proxy, deployment, service, pods. Okay, roles are not displaying here in the component side. So role is something like default setup. That is the reason we are not able to see that one. We have to find that what it may be. That is the default for the Kubernetes. We are not able to see as a component here from the cluster side. Role is nothing but the authorization, giving the authorization. So now here, let's try to access it. So to access it, Prometheus dashboard using the node port. So what is the node port here? Go to the service, deployment, replica set, service. So now here in the Prometheus is running with the 30,000 port number. So go to your node browser and give 30,000. So if everything goes fine, it has to come up with the Prometheus monitoring tool. So this is what the Prometheus monitoring tool. You can create the alerts, you can see the a graph, you can check the status, runtime will come align with configurations, targets, rules, the go to the targets. Right, so here you can see metric server is installed. This is the endpoint of metric server, API server on the cluster side. And CAD wise, total three nodes are there on the cluster side, one mastering through two slaves, and the endpoints, the services, total three services, metric servers. Like likewise, you can see the cluster details, whatever is running on the cluster side, and likewise you can see the configurations, the complete configurations. Right? This is a kind of monitoring tool which you can see the details. So go to the dashboard. Right here you can see queries. You can execute the queries. There are the number of queries are available in the Prometheus. Right, so here, whatever the details you want to fetch, you can execute these queries and you can get the details. Right, let's see here, example. We can check the Kubernetes metrics, kubelet running pod count. So here I want to see the pod count, the pod details. So what I will do, we'll go to here and here, go to the kubelet. So these are the kubelet, our Kubernetes commands. So now here you can see there is a query called kubelet running pod count. Click on execute. Right, so here you can see the pods. There are total three pods are running on the node 17 right here, and this is the host name and the OS details. Right, so the value, for the value there will be some representation will be there. Right, so here likewise you can get the details, but we need to understand these formats again. What is the value for the node Prometheus? So I can get the details running container count. I want to see the containers. That's the same now because parts are nothing but the containers only. The parts will be hanging the three containers. These are the containers. So now the value is changed here. You can observe here. And likewise, you can see these details actually. The metrics details, you can run the commands, the queries, and you can get the details like this. You can add the graph, means add one more query section, and you can run one more query section like this. You can add multiple graphs also. Right. So now this is not the somewhat understandable format, but for us, right? So this is not the understandable format, right? So we need to see the understandable format, human understandable format, or we need to go to the Prometheus material and try to understand these properties. What exactly is representing here? What is the value means? That's what we need to understand. So now here, this Prometheus can be seen in a graphical representation so that you can understand easily, not into the queries format. So that's where the Grafana will come into the picture. Prometheus is the one where you can execute the queries and you get the results. Then if you want to see in some better visualization, then Grafana can be injected or Grafana can be uh, configured with the Prometheus. So for that, go to the Grafana directory. So now I'm trying to inject the Grafana. So go here, right, then go to the Grafana directory of the monitoring ls Kubernets 1. Go to the monitoring ls. Now go to the Grafana. There for the deploy, right? So for every container, every pod, you require the deployment, you require the service, right? Deployment is for to create the containers, pods, and the service is to access it. So this is the configuration file. So now here in the config map pointed Prometheus DNS name. This is the config map. Let's open and see cat Grafana data source config file. Okay, so here this is the configuration file. So now how this Grafana will be interacted with the Prometheus means this is the stuff. Prometheus server. So now this Prometheus server will be added into the Grafana so that this Grafana can be interacted with the Prometheus, which we don't need to do any changes because this is the DNS name of the Prometheus. It will be taken care. So now here kubectl, this is the internal, right guys, port number, right? So if you guys observe here, Grafana is running with the 30,000. This is for the external for us, not for the cluster. Cluster will be interacted internally. So the internally the port number will be the 8080. Don't confuse that. Kubernets, sorry, kubectl apply -f dot. I want all the files. All the files means I need to deploy file. I need to deploy the config. I need to deploy the service where I want to deploy into my namespace called monitoring. Otherwise, it will go to your default namespace, right? All the monitoring tools I want to deploy into my monitoring namespace. I don't want to distribute between the namespaces. That is the reason this Grafana also I'm trying to deploy into the monitoring namespace. -f. Enter. Monitoring is not matching. kubectl get ns. Spelling down. Now here those are created. kubectl get all -n monitoring. Whatever. Spelling down. kubectl right, you can see now Prometheus and Grafana. Prometheus and Grafana. 32,000 is for the Grafana. It is coming. So by default password is admin. Loading Grafana. Due to internet issue. Otherwise it will be loaded quickly. So now welcome to Grafana. Then give the username as admin and password as admin. Login. New password. Some new password. Again I am going to use admin only. Admin. Subject. Invalid expired password code. Right, this is somewhat the visualization for your cluster monitoring Grafana. Okay, right. So here go to the left side, click on the plus symbol, then select import option. From here, click on the import because I want to inject my Prometheus monitoring tool to Grafana so that I can visualize better. Right. So now here, click on import. So now I'm trying to import the Prometheus into the Grafana. So now here from here, From here, the template number from the Prometheus is 8588 is the Prometheus template. So now here select the 8588 and click on load. Click on load, you will get the below screen somewhat. Right, so you will get the options, and in the options side, here you can see the name folder. You can leave it as it is, UID. Here you need to select the Prometheus, our Prometheus. Then click on import. The rest of the fields you can leave it as it is, just simply select the Prometheus. So now here the Prometheus will be injected, the Prometheus will be injected to the Grafana. That's it. See here. So now here you can see utilizations of the deployments, CPU utilization, or replicas. And if I go to scroll down, right, your API server details, max and current counts, right? So much. Just to go, try to go to the Grafana tutorial so that you can explore more how to utilize, how to use this Grafana. These are the complete details. Right? So at this point, CPU is nice because we tried the HPA metric server. So now here, if I go to up, my deployments, my daemon sets, my nodes. Or if you want to go to node wise, you can select the particular node consumptions. This is total nodes level. 1.364 something like that. Right. So now here, okay, fine. This is somewhat then. What are the queries I am trying to execute from the through the Prometheus? I want to see from the Grafana side. Right. So now here you can get the details out of like because I want to inject the Prometheus. I want to see in a graphical fashion. Right. This is the time frame, guys. You can do more exploration. You can get the more details. Like just try to explore the Grafana side. So now here, let's go to the plus symbol and click on the dashboard. New dashboard came into the picture. Then here click on add new panel. Right. So now here I want to create my own dashboards. So every time I don't want to go and fetch the queries. Then here dashboard, click on the new panel. Here in the new panel, name, give some name. In the panel section, give the name of the panel, some pod count, and under visualization, select the visualization mode. So panel title, I'm going to use pod count. Under the visualization, I'm going to give some graph, something. So this is some visualization, right? Different visualization styles for the dashboard. So now here, okay, fine. So now here, this is the panel which you want to create. Pod count panel you want to create the dashboard. Right. So now here, how you are going to get the pod count? The query has to be executed. The query has to be executed. Right now, who is going to execute the query? Your Prometheus. Right there, we have seen how to get the pod count. So that's what here. The Prometheus we are using and the displaying the visualization for the visualization we are using the Grafana. So right. So now here under the query tab, choose the Prometheus. Right. So here query tab, choose the default from the default of Prometheus. So now here from the Prometheus, we need to run the query. Prometheus in the metric section, give the query. You can get the query from the Prometheus metrics. So here on the metric section, enter the query. Kubelet running pod count. kubelet running pod count. Okay, or content. So as of now, let's take the pod count. Then save the panel. You can see here, this is what your pod count dashboard. 7 are running 9, the utilization of the details, likewise. So likewise, we can create our own panels and we can see the details. Right guys, so this is how like you can have your what's called, you can refresh it so that if any count any pod count is increased, then it will get the updated one. Right, so likewise you can have the dashboards with the Grafana and you can get the details like what the consumption of the resources from the Prometheus by running the queries. Now the Prometheus can be integrated with the Grafana for the better visualization. So if I go to my dashboard, then I can go to my previous state. Right. Right, guys. So now this is one set of monitoring tools. Prometheus and Grafana are the open source from the Kubernetes side. We are going to get to monitor our cluster. There are other monitoring tools also available in the market to monitor our cluster. Okay, let me show you the other tool also, which is also open source. Okay, so for that, what I'm going to do here is wave scope is also one type of open source monitoring tool to monitor your cluster objects of the components, whatever it may be. Right, so I will go to installing. Kolobnix is the guy. Go to this link. This is the Kolobnix is the link that I was. So from here, scroll down. You can see installing the web scope. Just simply copy this command. You don't require to do anything. Just copy the command. This is the setup command. So now go to your cluster. Right. So here, just run that command. So now it is going to create a namespace called wave. In the namespace, it is going to deploy all the required objects. kubectl get pods -n wave. Wave is the namespace it got created. So now here there are three agents and the Webscope cluster agent is created. So these three agents are nothing but, right, you want to monitor the cluster. To monitor the cluster means a agent has to be running inside the each and every node so that it can get the information. So automatically, when you run this deployment, you can go to this directory and you can verify the file also. What exactly this is? Right. So now here is going to deploy automatically one agent onto each node of the cluster. Simple. That's it. So now here kubectl get svc hyphen n wave because I want to access the wave swap node port. Right. So here my svc is not set up as of now for the wave. Okay, spelling is wrong. W A B G. Yeah. So now here I can say wave swap is set up, but it is the setup type is cluster IP. If you guys remember, the service types are different service types we are having: cluster IP, node port, load balancer, external name. Cluster IP is being utilized only for to access the services inside the cluster, not outside of the cluster. The communication will be happen between the pods inside the cluster. So means you cannot access it if I have the cluster IP. So now what I need to have, either I need to have a cluster IP with the node port, either I need to have the cluster IP with the node port. Either I need to have the load balancer or I need to have the node port. For the kube admin setup, kube admin ADM setup, by default we are not going to have the feature of load balancer. Now you need to set up the load balancer separately, mere uh, better level to be set up. Otherwise, we are not going to have the future. When we are going to have will be set up on the cluster or go to the AKS Kubernets. There by default will be having the feature. Okay, forget about the load balancer. Is the node port. So now here the IP cluster IP with the node port. Then we can get the node port number. So for that, this is the setup. And so wave from the wave namespace, getting the SVC service object into a YAML file, Then change the cluster IP as a report. Wherever the cluster IP you are going to find in the YAML file, change it to node port. Then apply it, replace. Right? Replace the old file with the new file. That's it. So now here this is the command, nothing but simply it will take the SVC, then in the SVC it will search for the cluster IP and change it to node port. So that the deployment, the service type will be changed. Now try to run the cube get SVC command again. So now your cluster IP will be changed from the cluster. Sorry, your service will be changed from the with this. So now it assigned node port 769. Now go to your 30,769. So now this is one more monitoring tool for your Kubernetes cluster from the open source side, Wavescope. Now we are able to. Right, so here, this is the wave scope stuff. Now you can observe here processors, containers, pods, hosts, networking, CPU utilization, memory, the representation of the graphical or the table. If you want to see in the table format, right? If you want to see in the graphical format, right? So here, if I want to see the host information, my nodes, three nodes are running, the CPU utilization, load, and the memory, right? So likewise, if you want to see the running pods, now there are all the pods are running. This is the graphical representation. You can expand it, right? So if you want to see in a tabular format, go with the tabular format, right? Cube controller, wave scope, blah 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 blah. You can see all the namespaces are showing here, right? So now here, if you want to see particular namespace, so now here it is all namespace showing. Here you can see default dev environment, cube public, something like that, right? So if I go to the dev environment, I want to see my pods. These are our pods: Nginx, my app version 1, my app version 2. Now click on anything. If you want to see the logs, simply you can click on the get logs so that the logs information you can find it here, the particular pod. Likewise, you want to connect to the containers, the pods. Click on the containers. If you want to perform any operations, click on the containers. Now you can go to any container, my app. Then here you can see execute shell. Okay, it is not able to execute into my app. Let me go to the Nginx or some other one. Nginx pod. Click on the execute. Right, I connected it. LS. Likewise, right? So you don't require to run the kubectl execute or something like that. This is the one of the best open source tool we have. So you can perform the operations. You can check the logs of each and every containers, parts logs, and you can check the CPU utilization, everything can get it. With the namespaces, you can go with the namespaces, you can filter it. You want to only see the monitoring namespace parts. These are the monitoring Prometheus, Grafana. Okay, because I have selected dev also, that is the reason the dev is also showing. Let me unselect it. Right now, the only monitoring can see like that. Right, guys. So this is one more monitoring tool we have called Wavescope, which is open source, very easy to install and easy to understand our monitoring stuff of the cluster. Right, right. This is about our Kubernetes, guys. So please practice it. The PPT, whatever I have given here, go through each and everything. If I have the time, try to explore the options of this monitoring tools. Right. So now let me go to my project and we'll try to show you or we'll try to understand some other components. Like the some other component means the communication between the services. Right. Your front end, back end communication. Right. Your front end means your application. Backend means your DBs. How the app is going to communicate with the DBs. So for that, what kind of configuration we need to do? That's what most important for us, right? So let me go to, let's suppose I'm going to one of the service called transactions, right? So now here, let me show you the services. different services are running my parts, nothing but campaign, communication. These are my part of the application services. So now here I have shown you one of the service called transactions. If I go here, you can observe here, this is the transaction pod is running, right? So now here kubectl get pods hyphen n prior. This is one of the namespace. N means namespace. Barely communicate, barely hyphen db. Now these are the front end services and these are the back end services, DBs. For the front end, we are deployed in some other namespace. The back end is deployed in some other namespace. That is our wish. If you want to deploy both in the same namespace, you can deploy it. Or you want to, for the better maintainability, if you want to have any separate namespace, you can do it. So now here, this is the separate namespace. So now here you can see this is the front end service and this is the back end service, DB database. Now the database is running. For the database, one pod is running. For the front end, one more pod is running. Right. So now this, when the transaction entry or someone is into the transaction service, now the transaction has to communicate with transaction DB. Correct? So the transaction should happen. Right. So how this communication API between the API and the DB will be happen. Right. So what kind of configuration from our end we need to do? Right. So now here you have to work with the developers to set up this kind of configurations. Solo, we cannot do it. We cannot do it means you have to be understand from the development side. Then only can do it. Otherwise, we need to get the help from them. So now here, let me show you how to do that one. So what we have done here is in the particular repository, config files. Right. So now config file. What is the config file here? So the configuration files are nothing but environment variables from the cluster side. Environment variables. Right. So now here, what is the environment variable? Like your Java path, your Maven path, all those are the environment variables. Right. So now here, if you want to set up the environment variables on the cluster side, you can use the config maps. From the container side, env. From the cluster side, config map. So now here, if I open the config map, what kind of environment variables we have configured? Right. So this is the kind you can observe config map. Right. As of now, you are saying deployment, service, pods, replicas, or something like that. Now there is one more object, config map. So what the config maps will do, it is going to configure the environment variables in the cluster. Nothing but wherever whatever the pods are running, whatever the pod you have configured this config map on the pod, it is going to inject the environment variables. What are the environment variables are here? These are the variables. That's it. So now this is the config map. Data means your environment variables information. So now let me go to my cluster again. Kubectl get config maps. Right here you can see a config map for the transaction. Right. So see the linkings. So one API is running. The API has to be communicated with the DB. For that we are running one more container for the DB. Then this is the linking, the configuration from the app to DB. The configuration we have provided in the config map. So what kind of information you have provided? My connection strings. You can see connection string for the transactions. What is the connection string? Your DB connection string. So now here API has to be communicated with the DB. So how the API will be communicated? The API needs that DB information like DB port number, DB username, DB password. So once the API got the information, then it is going to use that information. The information nothing but the authentication details. So with the authentication details, the API is going to connect to the database. How it is going to connect? this connection details has to be given in the code side. Now that's where the developers help is needed here. So now what we are going to do here is, whatever the connection string is there, whatever the connection string is there for the DB, the connection string details we are going to provide. We are going to provide to a environment variable, something like that. So now this is my environment variable. This variable is holding the DB connect communication details. One is the host, means where the DB is running, and the second one is the username. To connect the DB, right? I require the username, and this is the password we masked up because it is a sensitive information. And the which database in the DB, what database you want to connect. I want to connect to the transaction database, and what is the port number for the DB. 5432 is the port number for the DB, right? So now this is the communication details, nothing but the connection details for the DB, which we are providing in the config map as an environment variable. Then what is the variable here? This is the variable here. So now what the developers will do, simply when they want to connect to the database, right? In the code, when they want to connect to the database, simply they will use this variable. That's it. So now this variable, once the variable they are using in the backend, in the cluster side, this variable will be triggered. So now what the variable here is, this is the communication connection string details. So let's go and see from the code side. So I'm going to copy the variable name, environment variable name. Then I will go to my code base. Right, so here my code base, this is the code base, the development code side. So now here for the .NET side, I will be having a repository called API, sorry, directory called API. And in the API, we are going to find a file called startup.cs file. So it is going to launch. It is going to launch the application. So what the default settings you want to launch, that will be defined in the startup file. So I'm going to search for my communication details. See here, add the context to the DI container, right? So now here they have defined a block. In the block, when they want to connect to the database, they are using the environment variable. So this is from the code side. Get the environment variable. What the environment variable here? This is the environment variable. Nothing but my communication of the DB details, which is configured in the configuration file. So now this variable will pick the all the data, then it will going to connect to the database. So now this variable will be connected to the database. So now this variable will be connected to the database.
Hello, Shankar? Hello, Shankar? Shankar, we can't hear you. Hello, Shankar.